Alright, so we are analyzing the problem of f of x equals 2 minus 3 over 2x plus 2. And the parent of this graph would be simply f of x equals 1 over x, which appears like this. Like that, alright? So basically this graph is transformed a lot, and the first transformation would be if you work from the inside out, would be this plus 2 term, which would make it appear like this now. Alright, so it shifts it over -2 because it's actually minus in the original equation. The next we'd acknowledge would be the 2 here, which would vertically expand, or because it's in the denominator, shrink it or squish it by a factor of 2, which will make it look now sort of like my half-drawn graph, like this. So now that it's actually at 1 right now. Then we have the -3 next because it's minus 3, which, because it's negative, would reflect it about the x-axis and would vertically expand it all by a factor of 3, which would look in a flipped version sort of like and expanded like that. And I'll draw this one a little better, like that. And then the last and outermost thing we would do would be this plus 2 here, which would shift the whole graph up 2 x values, making it look like that. And then like that. So this graph is obviously discontinuous because it has 2 asymptotes on it, which would make it infinitely discontinual, or have an infinite discontinuality. And that's because it fails test 1, which is for every value that you can plug into x up here, you will get an actual outcome here. And if you plug in f of -1, then you get an undefined value because you divide by 0, so you can't do that. And the asymptotes of this graph are found at 2, because and that comes from the adding 2 here, and from at 1. And the 2 would be a horizontal asymptote, and the 1 would be a vertical asymptote. And the last thing about this function is we wanted to see if the inverse of the function would be a function itself. And if we run a quick little test here, we can quickly see that yes, it passes the horizontal line test, which would make it yes, the inverse of this function would be a function.